Vector in C++ is a dynamically sizable array, and the sizing itself is done at runtime, not compile time. So the ability to accommodate additional elements or deletion of it is a function of a runtime behavior built into the vector itself. So you can think of a vector as dynamically sizable array with that resizing capability. And since vector is just an array, it shares similar characteristics of an array, making use of contiguous storage locations for their elements, and all of the elements must be of the same data types. Vector in C++ is what we call standard template library. It is a set of C++ templated classes to provide common programming data structures and functions. So vector falls into one of those data structures that C++ support. To make vectors available in your code, you have to do #include vectors. This allows the preprocessor to pull the vector class and its functionalities into code, and the use of vectors is under the std namespace. If you don't want to use std : you have to put in using namespace std. That way you can reference vectors or v directly versus appending an std : in front of v every time you use it. Since vector is an array, you can look at vectors as literally like this, starting with index 0 all the way through n. And the ability to resize itself is done automatically. In addition to random indexing, and this is what we call random sequential. So this is what we call random sequential ordering. In addition to random sequential ordering, vector also has its own iterator that iterates through every single element of the array, forward or backwards. Notice that insertion of data or removal of data happens at the end of the vectors. This is the same thing as in array. Plus is insertion, minus is deletion. And notice that insertion of an element does not take O of one time, because remember, vector is dynamically sizable. So if in fact the newly added element exceeds the capacity, which is n in vector, the first thing that vector needs to do is to expand itself. And the expansion of the array to accommodate the newly inserted element takes differential time, meaning nonlinear, because you have to malloc or dynamically allocate memory spaces for extra vector elements. And the amount of expansion could be double the original size or could be increased at a percentage. This is the reason why it takes differential time to increase or expand the size of a vector to accommodate additional elements. Notice that vectors works with generics. Generics is a very popular concept that allows you to specify the data type of your element upfront and instantiation type. So in the event where you had to instantiate or create an instance of your vector, you can specify the type of your data sitting inside of this array or vector. The notion of generic is encapsulated between the two angle brackets. Let's look at some of the more popular operations in vector in the next slide. Just like an array, you can invoke some of the common methods inside vector to ascertain elements. For example, accessing elements at specific index. Or you can use the bracket operator as you would with array to specify the element by its index. You can also invoke its front and back to access the first element and last elements respectively. There's also this very popular pushback and popback mechanism. So if we to treat your entire vector as a stack, push means you're inserting elements into the stack. Pop means that you're removing elements out of the stack. So you can use push and pop, and also clear as in clearing the content inside the vectors as a whole altogether to sanitize your entire vector or resetting it at the end of your operations. Vector also has this notion of iterator. So this is essentially pointer-based methods that allows you to iterate through every single element starting from the beginning to the end of your vector. Notice that the syntax involves the use of understanding of vectors as well as pointer arithmetics. And pointer is the topic that we will talk about in a different video. There's a lot of literatures online that talks about vector operations. There's also a lot of demonstrations and code online that illustrates the use of vectors. I'll elicit some of those in the reference section of this slide.